Welcome back, my friends. We are going to talk about multiplying and dividing real numbers. So we're going to do 2, 4, and 2, 6 together because it's pretty easy, and they go together pretty well. I am going to skip part of the notes and you'll see a bunch of stuff blacked out. So the term multiplicative identity, just think back to what we talked about when we did these with adding. In adding, we added 0 because that's how things kept their identity. In multiplication, we need to multiply by 1 in order for them to keep their identity. So when it talks about multiplicative identity, it's just fancy terms for saying what number do you multiply things by when you want them to stay the same? And your answer to that would be 1. So let's talk about this. This is the gist of multiplying signed numbers, meaning positives and negatives. So the product, meaning the answer when you multiply, of two real numbers with the same sign. So they can both be positive or they can both be negative, is going to be positive. So a 5 times a 2 will obviously stay positive. And here, a negative times a negative cancels itself out. So they cancel out in pairs. And so 4 times 5 is going to be 20 as well. But if you have two real numbers with different signs, then that is going to turn out to be a negative answer. So it's like you have a leftover negative sign. So here 5 times 3 is 15, but you have a leftover negative sign that didn't cancel with anything else. Same thing here, 8 times 4 is 32, and that negative hangs around because there wasn't another to cancel with it. Alrighty, so if we just go through here and we take a look through these are of the same sign, and so they'll multiply to be a positive 21. Here you have you have 3 numbers. So if you do 3 times 4 first, you're going to get a 12, but that still has to be multiplied by this negative 2. And now you have one positive 12 times a negative 2. So my ultimate answer is a negative 24. And I could look in this first original setup and see that there's only 1. So there's nothing that's going to cancel it out. Whereas here, I see that there's 2 negatives, so they'll cancel out and turn positive in the end. If I do it step by step, a fourth of negative 16 is going to turn into a negative 4. And you could do, just think about 1/4 of 16. So if you cut it in half, you'd have 8, and then a half of that would be 4. But now I have 2 negatives, so negative 4 times negative 3, so I end up with a positive 12. So here you had, you really just are watching for those same signs. We're going to just get rid of some of this stuff over here and just talk about the problems themselves. Alrighty, so then let's take a look at these. They gave us these big giant boxes to do these two problems. So these two are negative, and so they'll cancel out to become positive. Here, these two will become a positive 6, but then I still need to multiply by this negative 7, so ultimately my answer is a negative 42. All right, so we talked about properties the other day, and we're going to talk about them again here for multiplying, and they're really similar to what we talked about. If you remember from last time, commutative had to do with the order. So we would do like A plus B equals B plus A. Same thing here, except we're doing multiplication. So A times B is the same as B times A. So whether you take 2 times 3 or 3 times 2, you end up with the same value. That's what that one is telling you about. Okay, so here 3 times 4 could be written as 4 times 3. That's just an example of that. Same as last time when we did the associative property. Associative had to do with grouping, who you associate or are grouped with. And so here, if you read this ABC, this side will stay ABC as well. The only thing that changed is that they were grouping A with B. Now they're grouping B with C, and those will come out to be the same answer. It doesn't matter which ones you group. So for example, here, 2 times 3 times 4 and 2 times 3 times 4 is the same whether you group the 2 with the 3 and do that part first, or group the 3 with the 4 and do that part first. In both cases, you're going to get 24. It doesn't affect your answer to move those parentheses. Identity, we talked about this earlier. Identity is the number that lets you stay the same value. So if I have A times 1, that's the same as 1 times A, and in the end I get to keep my identity. And so 1 is the number that lets me keep my identity. And property of 0, the product of a number and 0 is 0. So whether you take a times 0 or 0 times a, you're going to get 0. So 0 times anything just becomes 0. So here, to get 0 as an answer, 4 would have to get multiplied by 0. Similarly, if you think of multiplying something by a negative, all that really does is it changes the sign. It does not change the value. So a times -1 or -1 times a just turns it into the opposite of what you started with. So here a -5 times -1, it doesn't change it from being a 5, but it does change it into a positive number. So let's see if we can identify when they're using each property, and we can sneak back and look at them. So look at it and see what they're doing each time. So what they're doing here is they're multiplying by 0. So if I go up here and look, that's going to be my property of 0. So this is going to be the property of 0, meaning anything times 0 is going to be 0. How about if I look at the next one? What did they do? They took t, multiplied it by 1, and it stayed t. So when you get to keep your identity, that is going to be the identity property. Alrighty. In the third one, they did a times 3 and 3 times a. So they shifted the order of things. And just like with addition, the order property is called commutative, back and forth. Like you commute to school, commute to work, you go back and forth. So here, this is going to be the commutative property. And then in this next one, if you read this out loud, n times 3 times 5, n times 3 times 5. So they didn't change the order. They just had the parentheses around 3 and 5. Now they switched the grouping, so it's around the n and the 3. So if you remember back here, when we did the associative property, that's the one that has to do with the grouping symbols. And so in this case, since what they did was change the grouping symbols, that makes this the associative property, who you associate or are grouped with. So the 3 associated with the 5, then here it went with the n. Okay, so then this last one, they multiplied by a -1 to change the sign. So the -7 became a +7. And if you remember, that was our last one, which is just the property of -1. That what -1 does is switch signs. So this is just going to be the property of -1. So those are kind of tricky things, and you just have to learn them through practice and thinking about them. Here it says again, identify the property. So that's the same thing. -4 times 0, that's our 0 identity, our 0 property. Alrighty, then what's happening here? 6 times 2, 2 times 6. So they changed the order. That's our commutative, back and forth, back and forth. So that's our commutative property. 4, 5, 6, 4, 5, 6. So they didn't change the order. They changed the grouping. They changed the 5 associated with the 4. Now it associates with the 6. So this is the associative property. And lastly, they used a -1 to swap the sign out, and that's just our -1 property, which is not a very creative name, but that is what it is. Okay, so we're going to skip all that because that's just more of the same. So let's talk about dividing. Dividing real numbers is really super similar. We're going to use the same rules for signs like positives and negatives, but just like with subtraction, we changed it to adding the opposite. We're kind of going to do the same thing here, and we're going to, instead of truly dividing, we're going to multiply by what we call the reciprocal. And so we don't really call it the multiplicative inverse very often. We call it the reciprocal. And the reciprocal basically is just going to be you flip it over. And so if I have an A, I'm going to multiply it by 1 over A to come back and get a 1. So let's say I had 2. The multiplicative inverse or reciprocal of that would be a 1 over 2. If I had a 3/4, the reciprocal or multiplicative inverse would be 4/3. Okay, so inverse property. So the product, which is just talking about the answer of a multiplying problem of a non-zero number and its multiplicative inverse is 1. So that's what I was showing you up here. If you did 2 times a half, you would get 1. If you did 3/4 times 4/3, you would get 1. So what happens is if you think of this is like a over 1 times 1 over a, and everything cancels out. So you just get a 1 as long as a is not 0, because if a was 0, everything becomes 0. So same thing here. This is the same as saying 4 over 1 times 1 over 4. So the 4's cancel and you just get 1. So that basically a number and its reciprocal cancel each other out. So we're going to find the multiplicative inverse or the reciprocal. I think that's just the word you're going to hear more over time. So the reciprocal of 9, if you think of 9 as 9 over 1, the multiplicative inverse of that is going to be 1 over 9. You just flip that thing over. We don't have to do this reason. The multiplicative inverse of negative 5 over 6 will be negative 6 over 5. It doesn't really matter where that negative sign is. It can go out with the 6, the 5 out in front, as long as you have a negative, because you don't change it from positive to negative, you just flip it over. So that's all you do is when you are asked for a reciprocal, just flip the number over. So try these real quick and then look and see if you're getting the same thing as me. Thinking of that as 3 over 1. So you're not doing any real hard math, you're just flipping it over. And when you have a whole number like 3 over 1, then that becomes 1 over 3 when you do its multiplicative inverse. So the division rule, again, we're not really going to end up dividing, because the division of a number by a non-zero number b, multiply a by the multiplicative inverse of b. Okay, what does that mean? What that means is that when you're asked to do a divided by b, you can just do a times 1 over b, as long as b is not 0, because the whole problem will become 0 then. So if you're supposed to do 7 divided by 3, you can turn that into 7 times 1 over 3. Thinking of 7 as 7 over 1, I multiply the tops, I multiply the bottoms, and my answer just can stay as 7/3. The quotient of two real numbers with the same sign is going to be positive. So again, if you have a positive over a positive, you get a positive. Negative over a negative, you get a positive, because they cancel out in the same way they did with multiplying. If you have a positive over a negative, however, that is going to become a negative, or a negative divided by a positive. So again, if there's one negative rather than a second one that it can cancel with, your final answer is going to be negative. And if you're ever taking 0 dividing by a number and you don't believe me, you can check it out on your calculator. You're just going to get 0 every time. So here, 25 divided by 5 is the same as 25 times 1 over 5. So if you think about that, you can say, well, 25 over 1 times 1 over 5, multiply the tops and the bottoms, and my answer would be 5. And since they're both positive, my answer is positive. Now this one's going to be trickier. You probably could have done 25 divided by 5 in your head, but when you get more complicated numbers, you want to have a way to do it. So like I would think of this as negative 40 over 1, because it's not a fraction. And instead of dividing by 2/3, I'm going to multiply by the reciprocal, so 3 over 2. Then I can multiply the top numbers, and keep in mind one of them is negative and one is positive, so I get a negative 120. When I multiply the bottom numbers, I get a 2. And then negative 120 divided by 2 lands me at negative 60. Okay, so again, this is division, so I'm going to change that to multiplying by the reciprocal. This is the one that gets flipped. I multiply the top numbers and the bottom numbers, and then I would reduce my answer, because 2 goes into both of these. So they can both be divided in half to give me my final answer. So a lot of little things to think about. This one looks tricky. This is going to be 16 over 1 times the reciprocal, which is actually going to be negative 4 over 1. So you end up multiplying these top numbers and the bottom numbers for your final answer of negative 64. And it's negative because I have one negative number and not another one to cancel it out. All right, so these look a little fancy and really complicated, but what you can do in this situation is you can say this is the same as the top part, like what we've been doing, over 1 times 1 over 8, if you want to think about it like that, divided by 1 over 8, because this fraction bar means divided by. And so here, if I'm doing this divided by 8, I could multiply by 1 over 8. And then I'm really just going to be multiplying each piece. Since this is parentheses, each piece is getting multiplied by 1 over 8. And so this part would, if I think of that as having it over a 1, I'd end up with 48y over 8. This part, I'd get negative 32 over 8. But each of those things reduces because 48 divided by 8 is 6y. 32 divided by 8 is 4. So I actually think that's a kind of really tricky way for them to have you do it. What I would do and what I teach my kids at the high school, so I'll just show you this and see if you like this way better. I just split this up. I write this as 48y over 8 minus 32 over 8. Since they're both over 8 and these are separated by subtraction, I can just split it up. And then that way I can just take this and divide it down to 6, take this and divide it down to 4. So if that process makes more sense to you, then like here, since they're both over 2, I can separate them out. This one does not reduce, so 3a over 2 stays the same, but this one can turn into a plus 2. I just think that's a lot easier. Same thing here. I can take 12x over 4 minus 8 over 4. This can reduce to 3x over 4. This can reduce to 2. So multiplying, dividing, positives, negatives, some fractions, a little bit of that kind of stuff. So when you get to do this, we are going to be looking at an IXL. I will have in the daily plan which one you need to do, but do these for practice. And again, you're aiming for a score of 80 or higher if you want full credit or extra credit. Anything less than that will just count as whatever you get. So if you quit at 62, you will have a 6.2 out of 8 for the assignment. So have a great day, you guys. I will see you later.